Let's talk about the exciting topic of using data analytics to make decisions. Organizations has been making decisions before the era of computers. There are a variety of decision-making methods. Sometimes we decide to continue past actions or traditions. Often we see business leaders follow their intuition or sixth sense. This isn't something rational but has a lot of value to it. Rules of thumb are a simplified version of rational decision making. For example, to determine which vendor you should choose to supply your products, you could be looking at a large number of factors, such as the efficiency, the pricing, the quality of the service, the longevity of the business, size, and etc. etc. Or you can choose one key factor, maybe the price, as your determinant factor, which will make the decision process really quickly. Another frequently used rule of thumb is recognition. This is when people tend to go with the names they recognize. However, people may recognize the name of a vendor because it has been in the news. Maybe the news is negative that the company is being sued. So as you can see, while rules of thumb can be quick decision-making approaches, it is flawed. The rational decision making is when you rely on analyzing relevant data. In today's environment, often it is facilitated by the use of software tools and data analysis methodologies and models. It is important to be aware that these are not mutually exclusive methods. A good data analyst should trust their intuition or instinct, and then they use the data to validate their gut feelings. Data analytics is a scientific process of transforming data into insights for making better decisions. So again, this is objective, data-driven, fact-based, so it's different from intuition or rules of thumb. From a model perspective, data is coming in from the left side, and then they get through different tools and techniques to analyze the data. At the end, you're providing and extracting business insights. So this is a very simplified version of looking at analytics. But in reality, it is not very clean. You have all different kinds of data. There's very good data, but also you can have very messy data. And you can also have data that's erroneous, that's entered incorrectly by the customers. Then it can be further complicated by data that's missing. Then you have to use different techniques to clean up the data, funnel through different methodologies and methods. At the end, you might have some useful business insights, but it's also coupled with many different types of noises. In today's environment, we are more and more driving to collect data that's in the category of big data. Just imagine your business has to account for data generated from your social media platforms in addition to the traditional organizational data. If you're Netflix, just imagine your customers are watching 10 billion hours of programming on a streaming basis every month. So you're capturing data constantly as the viewers are browsing, and you're measuring how long they're looking at any program and the genre they focus on the most, and what they watched and what they abandoned. Again, the data is generated on a real-time basis. So to work with such data, you need to funnel them into a much more sophisticated type of data engine, such as Hadoop clusters. And then it can sift through this massive amount of data and then move them into more traditional ways of treating data, such as data warehouses, for the final analysis. At the end user stage, you can use tools like Tableau and visual graphics to represent the data. A little bit more on the big data characteristics. There are four main characteristics. As I described in the Netflix case, streaming data generates a massive amount volume of your data. Also, the speed at which the data is generated, or the velocity, is unprecedented. IBM reports that 90% of today's data has been created in the last 2 years alone. Think about that. And that speed is just going to be increasing consistently in the future. Any social media platform, for example, Facebook generates really massive volumes. They have close to 2 billion daily active users in 2020. If you have any kind of breaking news, can you imagine the data that can accumulate in matter of minutes? Unlike the traditional database, big data encompasses structured and unstructured data. There's text, images, videos, PDFs, Word files, you name it. So there's a lot of different variety of data. And also I mentioned earlier about veracity. The big data often contains a lot of ambiguities. And there's a lot of incomplete data and also missing data. So how do we reconcile these different types of data into a big data database? It requires a lot of different techniques. There are three main types of analytics we conduct. Descriptive analytics is analyzing what has happened. Think of it as looking at historic snapshots. Predictive data is looking into the future, what might happen in the future based on the past data. Prescriptive analytics is actually telling us what we should do based on what we have learned from the past. So descriptive data analytics is the foundational understanding of your data. Among the three, the most useful will be the prescriptive analytics. While all three analytics are useful and valuable, the prescriptive analytics is the most valuable because they are telling the business users what they actually should do. However, when you're in an environment that's experiencing a lot of different unprecedented phenomena, such as the pandemic we're experiencing, businesses tend to shy away from predictive and prescriptive analytics because there's no similar past data. Let's look into each kind of analytics in more depth. In descriptive analytics, you are describing what has happened. So you use the structured data queries. You can run business reports such as monthly revenue. You can run various descriptive statistics such as mean, median, mode, standard deviation, variance, correlation, and etc. We can also use data visualization, such as summarize data using tables and graphs. When you have a set of related statistics, you can actually create what's called a data dashboards. We can also use data mining techniques to describe past data. There are also what-if spreadsheet models that we can use to look into the data. Predictive analytics, again, is looking at what could happen based on the past to predict future, or you can ascertain the impact of one variable on another. In linear regression, that's what we're looking at, the impact of variables. I have an example here to show you. This is a paper I published in Psychology and Marketing in 2019. In this project, we look at the factors that affected the adoption of mobile payments in the United States. On page 3 of this paper, you will see a group of variables such as the responsiveness of the mobile payment, perceived usefulness, the attitudes you have towards mobile payment, all in conjunction determines the intention to adopt mobile payments. We can also use time series data to predict the future. In time series data, you can use the existing data to predict the future. For example, based on the pandemic data, you can predict when the pandemic would be over or the number of deaths at a certain point of time. Using data mining, you can uncover hidden patterns. For example, you can discover what products are typically purchased together, so you can use that pattern to enhance your product recommendations. When data mining first was introduced as a discipline, they analyzed the grocery store data first. They discovered that people buy diapers typically end up buying beer, true story. So such patterns can be quite unexpected. That can be really easily detected. So we can use data mining to provide these kind of insights. This can then be turned into really useful recommendations for grocery stores to how to organize their shelves. We can also use simulation to test certain types of events from happening and how they actually lead to certain outcomes. Prescriptive analytics is designed to tell you what you should do. It is still providing a forecast or prediction, but it doesn't provide a decision yet. When you combine the prediction with a rule, then that becomes a prescriptive model. For example, you can predict the probability of a person that might default a loan. Then you add the rule, let's say if a person has a less than 60% of the probability of defaulting a loan, then we'll approve that loan. Google self-driving car utilizes a tremendous amount of prescriptive analytics. If the car, let's say on the road, is detecting deceleration in front of you, and the car is utilizing satellite images, video cameras in front of you, behind you, on the sides, and it's detecting the rules of speed limit. And when it detects the deceleration in front of you, it will take that data input and predict a collision. However, prediction is not enough. It must tell the car to slow down to a specific speed, right? If it's not possible because maybe the car behind you is too close, then you are recommending changing the lane. So a lot of prescriptive analytics at work in that scenario. We can also use prescriptive analytics to determine the mix of a set of investment that can yield the highest return. The starting point of any analytics project is your business problem or question. So if you're in the retail business, you might be wondering, what products should I recommend to my customers, right? What are my typical customers? If you're experiencing business problems, you can be asking, what is wrong with my business? Is there something wrong with my ordering process? Is something wrong with my websites or customer satisfaction? If something about pandemic, you can ask the question, how bad is it? If you're in the healthcare business, patient no-show negatively impacts revenue. So we might want to know why patients miss their appointments. So how do we conduct an analytics project? Here's the process. We want to first have the data. Either you'll be tasked to collect the data or the data will be given to you. You will then store the data. Your data exploration stage is accompanied by the cleaning process simultaneously. During this process, you are trying to reach a clear understanding of your business problem. You build your business case. From a technical perspective, you are going to understand each and every relevant variable, and you're going to use a variety of descriptive statistics to guide your cleaning process. For example, during this process, you will run the standard deviation and mean for a variable, and from there you can identify outliers. Then you need to decide, how do I treat the outliers? Once the data is clean, you move on to the analyze stage, which is driven by your business problem. And you will further develop your business questions, and from a technical perspective, you will determine what tools am I going to use. Am I using Excel? Am I using Tableau, RStudio? And depending on the question you want to answer. Also, you're going to try to generate different types of statistics to answer your business questions. Part of the analysis is to visualize the data in step 5. So visualization can be using histograms, trend lines, maps, bar charts, column charts, or a table. When we're representing data, use some basic design principles. And also use color wisely to enhance your diagrams. Recently, I gave a phone reference for a student applying for a data analytics job. The interviewer said she remembers a diagram the student developed because it was a gender-based research. She remembered there were some pink colors for female data and blue for male. She saw that project about a year and a half ago. That says a lot about the power of visualization and color. You can never make that kind of long-lasting impression by using just text. The final step is also the most important step. That's when you translate data into insights. This is when you interpret your results and provide business recommendations. Business can then evaluate them and implement accordingly. Ultimately, they try to gain business values by implementing those recommendations. So they want to maybe increase their sales to gain more customers, more satisfied customers, reduce costs, and etc. Without this final step, you are simply conducting some data analysis. Thank you for listening to this. If you have any questions, please let me know.